Hi guys, this is a short course on calculus, and the purpose of this course is to gain enough knowledge to apply the operations of calculus in solving physics and chemistry questions. Yes, calculus is a math topic and it is having two major streams, which is differential calculus and integral calculus. Most of the differential calculus part is dealt in class 11 in the maths topics, which are going to come after a few months, and the integral calculus part is taken care in class 12. But unfortunately, for solving the physics and chemistry questions which involves calculus, we should be knowing at least the basics of differentiation and integration, and hence this course. So we'll confine the scope of this course to be able to solve the questions which might come in physics and chemistry involving calculus. So what is calculus? Calculus is in fact study of a continuous function, and the essence lies in breaking the continuous function. I'll be dropping in words like function and all, which I'm going to explain. So suppose there's a quantity which is varying continuously, and in calculus we are going to study it by breaking the continuous function in very tiny steps. So it will be tiny steps like this. It goes horizontal and vertical, and then doing the microscopic study over there. So these tiny steps are called infinitesimal steps, and calculus was earlier called calculus of the infinitesimals, and the major study was done by Isaac Barrow, an Englishman, and later on by Newton, as we know him as the father of calculus, and Leibniz. You'll have theorems by Leibniz in perhaps class 11 and class 12 also. And it is an interesting read that how Newton and Leibniz both claimed to be, they were at loggerheads, claiming to be the father of calculus, and the idea of these infinitesimal steps were their brainchild. So that's nothing to concern with us, and later on there has been a lot of change and a lot of rigorous study in calculus and a lot of techniques developed. So there are in fact many fathers of calculus. So this course will have two major parts in it, one for differentiation, that is differential calculus, and one for integral calculus, and both of it will require some basics like functions and limits, which I'll be discussing right now. So what are functions? There's nothing new over here. It's just a fancy name for what we used to call as y. Say y was 2x plus 1. So here x was an input variable. We are putting various values of x to get various outputs as values of y. So now instead of calling it just as y, we call it as a function of x. So what we have is function of x. Say it is defined like this, and then I say what is f1. It means wherever x is in the expression, you replace the x with a 1. So you get 2 into 1 plus 1, which is equal to 3. So this was and if I graph it, it is a linear function. We know it will have an intercept at 1. It will have a slope of 2. We'll be discussing slope later on, so don't get worried. And when we put various inputs, like when you put x as 1, so this is 1, almost this is 1. When I put x as 1, I get my y value as 3. When I put my x as 0, I'll get my y value as 1, and we'll get a linear graph. You can put several values and you'll get a graph like this. So what is happening is, we can say function as a machine or a calculator which takes an input. Generally the input variable is called x, and produces an output, and that variable is what we are calling as fx, or what we still call it as y, this being the y-axis. Instead of calling it as the fx axis, we call it as the y-axis. So this is your input and that's your output. This was a very simple linear function. The functions can get bit more complicated, wherein it can be a polynomial, something like this. And if I say what is f0, obviously 0 cube, 0 square over here, 0 over here, and what you're left is with just 1. What is f, say minus 3? Then a minus 3 whole cube plus 2 times minus 3 whole square minus of minus 3 plus 1, and whatever value it gives. So in maths you would be starting with trigonometric functions. So a function like fx equal to sin x, or fx equal to sin x plus say cos 3x, and I ask you what is f of pi by 6. Whether you know the value of sin pi by 6 or not is not the question. The point is whether you can replace the x's correctly with the input value or not, which is pi by 6 over here, plus cos of 3 times pi by 6, and whatever answer it gives you. So just to summarize, your function takes x as an input, takes a variable as an input, and produces a certain answer. So that input, if it is having a concrete value to it, the function is going to produce a concrete numerical answer. And then you can graph the answer produced as y on a coordinate axis of y versus x, and check out the graph. Like this cubic function will have two bends. This will be going to infinity down and then infinity up. Just to make sure that you have understood what is a function, just try out finding the value of these two simple functions. Mind you, function is a big fat chapter in maths, a lot of things involved, and we are just skipping all those things. That is not required for now, as our agenda is to learn how to differentiate and integrate, basically for problems coming in physics and chemistry. I hope you got the two function questions right. And now limits. So limits again is a big fat chapter in math, and there are various kinds of limit what you'll be evaluating, and it is quite fun doing those questions. But thankfully all those things are not required right now, and we'll confine our knowledge to limits, to be knowing enough to understand what how that differential and integral calculus is working. So what is limit? Limit is limiting value of something is when we don't know the exact value, but the value which is being approached. Like if I say the symbol of limit is either LT or LIM, various books will be using various, so I'll be using LT, one letter short. So when x tends to say 2, this arrow means it is not equal to 2, x is not equal to 2, but it is approaching 2. Now you might ask, approaching 2 from which side? Whether it is slightly less than 2 or slightly more than 2. Whether it is approaching 2 from the left hand side or the right hand side. So left hand side is like 1.99999 and right hand side is 2.00001. So x tending to 2 may mean a number which is very near to 2 but less than 2, and it's not a particularly defined number. It is a number which is quite near to 2, and you can keep on adding nines to it, and it will mean this, the more nines are there, it will mean it is tending to 2. It is almost equal to 2. And here also you can put millions of zeros and a 1, so it is almost equal to 2 but not 2. So when this arrow is there, it means it's not equal to 2, it is tending to 2. And then if there is a function over here which involves x, function of x, and let that function be a very simple function, say x square, then what's the answer? The answer would be limit x tends to 2 and x square over here. So if I say if it was 1.99999, my answer would have been very close to 4 but just less than 4, and had it been 2.00000 million zeros and 1, the answer would have been just more than 4. So the answer of this would be approaching 4. So since the answer of x square is approaching 4, the limit answer is equal to 4. We say the limit of fx when x tends to 2 is equal to 4. The actual answer is not 4 exactly, it is almost 4 from the left hand side or the right hand side. Now this left hand side or right hand side both would be approaching 4, so it's quite easy over here. But if I ask you what would be the answer for say a 1 by x, x tending to 0. Now you can imagine a number which is very close to 0 but not equal to 0. So if I imagine a right hand number, my answer becomes 1 by many zeros and 1, which is equal to a very large number, 1 and a lot of zeros. So it's a very large number, so the lower this number goes, this tends to infinity, so I can say my answer is infinity. But am I right? I am not, because if x was tending to 0 from the other side, that is from the left hand side of 0, the answer would have been 1 by minus 0.00000001, and hence equal to minus of a very large number, lots of zeros, I'm not counting the zeros over here, a very large number, and hence would have been a minus infinity. So a plus 10 crore or 10, 20 or 1000 crores is much different from a minus 1000 crores. So there's a big difference between the two answers, and both the limits, the left hand limit and the right hand limit, is not matching. So sometimes we don't have to bother about which side it is approaching from, because it gives you the same answer. Sometimes it gives you different answers, so you have to be a little careful about there. So all these things are dealt when you are doing functions and limits and derivatives later on, and continuity and differentiability, which are big chapters in themselves, but we will confine to finding some specific limits. I'll just clear the board. So when we are finding limit of a certain function which is dependent on x, and x is tending to a certain value or defined value a, say 4, 5, whatever, x is tending to that number, we can end up with various formats, like suppose a number p divided by tending to a number q, where p and q are not equal to 0. So this is hardly a job at hand. I'll give you an example. The example would be, say limit x tends to 2, you have 3x plus 4 upon 2x. So what would it be? When x is almost equal to 2, this guy will be almost equal to 6, plus a 4 will be almost equal to 10, divided by 2 into 2, almost equal to 2, gives you almost equal to 4. So almost equal to 10 divided by almost equal to 4 is a 5 by 2 or 2.5. So the limit answer will be 2.5. The answer is approaching 2.5. This guy is approaching 2.5, and the limit of this is said to be equal to 2.5. So we got a 10 and a 4 approaching to 10, like this p approaching to 4, like this q. So this is, I mean, hardly any concepts of limit is required over here. It's just that it is a tending value, not an actual value. So big deal in this, nothing over here. The next kind, so I'll call it as kind 1. The next kind is a very similar kind, which is, say your answer is tending to 0 or exact 0 divided by tending to q. So if you have a number on top which is almost 0, divided by a number which is not equal to 0, say 4 in that case, what's your answer? Answer would be 0. So again, I'm not going to explain. I can write an example over here. Say x minus 2 divided by x square, limit x tends to 2. So what is it? The top guy is almost equal to 0, but the bottom guy is almost equal to 4, and hence your answer is 0. So that's your other kind. The next kind, number 3. can be, you have a number on top, tending to a number on top like that 10, divided by tending to 0 on the bottom. Now what can this be? What can this be? Here you have a number on top. I'll give you an example over here. Limit x tends to 2. I'll just reverse this. You have a x square divided by x minus 2. So what you have on top, it is tending to 4. On the bottom, it is tending to 0. And here, whether x was tending to 2 from the right hand side or the left hand side will tell you whether it is a positive side of 0 or the negative side of 0. If x was more than 2, it's a positive number. If x was less than 2, it's a negative number. Now, if you have 4, something near to 4 divided by something which is near to 0 and not exactly 0, then your answer would be a very large answer. So it can be either infinity or it can be minus infinity, depending on two things, depending on one thing, whether this x is tending to 2 from the right hand side or the left hand side. The above one is positive. If the lower one is positive, it is plus infinity. If the lower one is negative, it is minus infinity. So when this is the case, your answer tends to plus or minus, not both, plus or minus. We should have a well defined thing, whether it was from the left hand side or right hand side of infinity. And then the next kind can be you have something tending to p divided by an exact 0. Now if you have an exact 0 at the bottom, the answer is undefined. You may have something like tending to 4 divided by a 0. This is undefined. There is no number which when multiplied with 0 can produce a number which is near to 4. So there is nothing 0 into an undefined number can only produce 4, which is, it's not a possible thing. So the number is called undefined. You don't have a number like that. So the next one, so if you have an exact 0 at the bottom, the answer is 0. Next one can be a tending to infinity on top and tending to a pure number at the bottom. So if you have an infinite number on top and a normal number at the bottom, it is infinity. I'm not going to explain that. So if it was plus over here, it is plus infinity. If it is minus over here, it's minus infinity. So I've been using q for the denominator, so I'll continue with that. So what will this be? Tending to infinity at the bottom, what will this be? A normal number like a 4 or a minus 4 on top and a large number like infinity at the bottom, what will it be? So if you have a division by a very large number, say tending to 4 or say tending to minus 4, divided by a very large number, very large number, very large number, it will be almost equal to 0, right? So this will approach 0, so the limit value will be equal to 0. So these are hardly a problem to be evaluated. Now the problematic ones are this case and this case. What is that? A tending to 0 divided by a tending to 0. Now this is not an exact 0 and this isn't an exact 0. So this is where you'll have to do some math to get the answer. The answer can be as great as plus infinity, as low in value as 0, as low as minus infinity. So the answer can range from plus infinity to minus infinity depending on what is making up that 0 and what is making up this 0. So this is the problem at hand. And the other problem at hand is this one. When the numerator is infinity and the denominator is infinity, but infinity is not a defined, it is not a number what we know. It is just a very large number, larger than whatever we imagine. But among these two large numbers, one can be larger than the other. Say x is tending to infinity, 2x is also tending to infinity, but 2x is always twice as greater than as x. Hence, this would be a problem in hand, and we have to know what this infinity is made up of and what this infinity is made up of to give you a proper answer. And in fact, this case and this case is almost the same case, because we can write infinity as 1 by something tending to 0, 1 by something tending to 0 divided by 1 by something tending to 0, and this goes on top and that goes on bottom and becomes the same case as this. But anyways, this and this is where we are using our expertise of maths and algebra to get a proper answer. Otherwise, these cases are hardly to be evaluated. Here you have to do some calculation. Here it would be 0, here it would be infinity, here it would be undefined, here it will be infinity, here it will be 0. So let us just do some problems. Let me make up a problem for case 7. So I'll write case 7 over here. Say limit x tends to 0, and you have got a x square divided by x. Now in itself, what is the top thing approaching to? The top thing is approaching to 0. The bottom thing is also approaching to 0, because x itself is approaching to 0. But we know one is much more closer to the 0 than the other one, because the x over here is the same as the x over here. It's not like these two x's are different. You have imagined whatever small number, how much ever small you can, but it is the same number over here and there. So if you say that this was 1, 2, 3, 4, 5, 6, 7, 8, 9, that is a 10 power minus 10, 9 zeros and a 1 was this, then x square would be what? X square would be 10 power minus 20. So you'll have 19 zeros and a 1. So even on doing the division, which is 10 power minus 20 divided by 10 power minus 10, you'll be still left with a very small number, which is 10 power minus 10, and hence we know that the answer for this will still be tending to 0, because the upper one is a much smaller number than the lower one. The upper one is much nearer to 0 than the lower one. So here the answer becomes 0, and the way to do it is, we'll try to make this case into one of these cases so that we can get an answer. So either the top or the bottom should not be tending to 0, and hence we can evaluate the limit straight away by putting the x value into the answer. So all the algebra rules hold over here, so we can cancel a x with a x over there, and this becomes limit x tending to 0 and x. So one of the x has cancelled and only x remains. These are the ones which are not of a problematic kind. So this is particularly of this type, tending to 0 divided by something which is either equal to or tending to a pure number, which is 1 over here. So this is 0. We put x as 0 over here and get 0 by 1, which is 0. So the answer is 0, and the thought process what should be going in your mind should be this, that the upper one is, if the lower one is a million of zeros and 1, then the upper one is 2 million zeros and a 1, and hence the division will lead to 0. If I flip the thing and ask you, say this is example 1, example 2, limit x tends to 0, and it is a x divided by x square. Now we know that you have a larger number on top and a lower number on top, bottom. Both are tending to 0 by tending to 0, but both zeros are not of the same value, and the lower 0 is much lower, and the answer for this should be infinity. It is 10 power say minus 10 divided by 10 power minus 20. There are so many zeros and a 1. I just noticed that it's not coming in the frame. Let me give you another question of this 0 by 0 kind. Say limit x tends to 2 and you have a x square minus 4 upon x minus 2. So we see that if we put 2 directly, we are going to get a 0 by 0, and which has got no meaning, and maybe the answer is not undefined. Exact 0 would have been undefined, and we get an answer by evaluating. So this is a problem at hand. When you have a 0 by 0 tending to 0 divided by tending to 0, we have got a problem at hand, and we have to see which 0 is nearer, and whether they have a certain ratio between them or not. So over here we can plug in a value which is very near to 2.20 zeros and a 1, and then check out what the answer is going towards and report that as the answer. But that is the tedious way, and that is not a mathematics kind of way. We'll use our knowledge of algebra to do it, and we will try to bring it to these simple formats where we don't have a 0 left on top or a 0 left at the bottom. So right now when we plug in a 2, we get a 0 here also and here also. So this is problematic. So we want to convert it into a non-problematic question, and we want to eliminate the thing which is making it a big deal, making it a problem. So one is factorizing. We know that x minus 2 is making the bottom as 0. So when x is equal to 2 is making the numerator also as 0, it must be a factor over there. That means the numerator must have a x minus 2 in it when we factorize it, and we very well know that x square minus 2 square is x minus 2 into x plus 2. So without a thought, many would have written straight away this thing, x minus 2 limit x tending to 2. Mind you, this is not an exact 0 and this is not an exact 0. When they are not exact zeros, we can cancel. They are the exactly same number. How much ever close to 0 it is, this number is exactly same as that number, and since they are not zeros, we can cancel them, and what we are left with is limit x tending to 2 x plus 2, and this is not a problem at hand at all. So when x is almost equal to 2, this number will be almost equal to 4. Whether it is a left hand limit or right hand limit, the answer will be almost equal to 4 from the left hand side or the right hand side. So the limit is 4. So the limit value of this is 4. So this is how we deal with a 0 by 0 question. What is making it 0 on the top or bottom? We try to eliminate that by factorizing as it has been shown over here, or other ways, and eliminate those questions. So similarly, we'll have a infinity by infinity kind of question, like say x tends to infinity, but I'm not going to devote much time to this because it is not required for the purpose what we are doing this course for. Say x cube plus x square plus x upon say 3x square plus 2x, x tending to infinity. If I plug in infinity on top, imagine a very high number and plug it on top, then what happens is the numerator is also a very, very large number, and the lower one is also a very, very large number. If we think of say 10 crores and we plug it over here, 10 crore cube will be much larger than what the squares will produce, and we know that this one is a much larger infinity. Even if we had a minus over here and a minus over here, a minus 1000x square over here, whatever, still this would be much larger, because as the number tends to infinity, this cube is going to grow at a much faster rate than the square, and hence it's a bigger infinity on top than on the bottom, and ultimately my answer would be infinity. So that's the sense. But if we want to convert, we want to have a concrete answer, we'll do some maths over it. Say divide with x cube on top and on the bottom. So what do we get is, we get 1 minus 1000 divided by x minus 1 by x square. We have it divided with x cube on top and x cube on bottom. 3 divided by x plus 2 divided by x square. Now if we plug in x as infinity, what do we get as? We get 1000 by infinity, which is almost equal to 0. This is 1 by infinity, which is almost equal to 0. These are the individual plugins. When we have put in infinity, then a number divided by infinity is almost equal to 0. So 0 over here, but 1 is left. So what we have is the top number is tending towards 1, but the bottom number is tending towards 0. This is 3 by infinity is almost equal to 0, and this is also almost equal to 0. So tending towards 0. So if we have tending towards a concrete number and tending towards 0, then the answer would be infinity, what we have evaluated earlier. Sorry, this one. So what we have evaluated by our logic, that this is a much greater than infinity than that one, and had it been say a square over here, then these are comparable numbers, and eventually you land up with, this is going to rule the numerator and this is going to rule the denominator, and you are going to land up with a 1 by 3 when you evaluate this. But don't worry, I'm not doing it, I'm not asking you to do it. The whole purpose of this is just to understand what is the meaning of limit, and you can evaluate simple limits like these or not. By the way, we have other kinds of problematic limits. One being, say, the 9th kind is a number which is tending to 1 raised to a power which is tending to infinity. So had it been a pure 1, the power is infinity or whatever, the answer would have been 1. But if it is not a pure 1, then if it is tending to 1, then if it is raised to a very, very high power, then the value may grow up or go down depending on whether it was left hand side of 1 or right hand side of 1. So had it been 1 point something, power infinity will make it a large number. Depending on how close it is to 1, may not be able to make it as large as infinity and just end up to a value which is near to 2, 3 or 4. And had it been on the left side of 1, say 0.9 is way left side of 1 and it is raised to power infinity, that will land you to 0, because 0.9 square will become 0.81 and the square of that will become 0.64 near to that thing, and slowly if you keep on increasing the power, the value will keep on growing lower and become 0. But if it is just less than 1, then it is raised to infinity. How low it can go, how much will it become, will be a question. I mean, maybe it lands up to a number near say 0.7 or something. So a tending to 1 raised to infinity is another problematic kind. We are not going to deal with it right now at all, because that is not required for the purpose of this course, which is knowing what is differentiation and integration. So in differentiation, you will need to know what is limits, a bit of it, and hence this was introduced. So don't worry much about it. Limit as a whole chapter with a much deeper and prolonged explanation and more time given to you to solve the questions. That kind of class is going to come later on, and you just need to know the word limit and should not get baffled when 1 or 2 simple limits are being evaluated. So just to check your concept, do these few simple questions on limit. Hi guys, I hope you got these quiz questions right. I'll just do it again for you to verify whether your thinking process is same as what is required or not. So looking at the first one, x is tending to 2. So let's see whether it will be a problematic limit or not. What's a problematic limit? When it is 0 tending to 0 on top and tending to 0 at the denominator. So just plugging it for the denominator, what we see is the denominator is not tending to 0. So if the denominator is not tending to 0, it's not a problematic kind at all. So whatever is the value on the top, we'll just plug in the value of x, and what we get as the answer would be our final answer. Nothing to do much over here. So basically, let me just plug in the values and see what do we get. We get a 2 minus 1 at the bottom, and we get a 2 square minus 3 times 2 plus 2 on the top. So what is this? This is a 4 minus 6 plus 2. So we are getting a 0. That means the value is tending to 0 on top. And at the bottom, what we have is a value which is tending to 1. The limit value of the expression, when I say limit extends to 2, the limit value of the expression would be 0. This is not a problematic one, because what it means is a very small value, almost 0, divided by 1 is answer is almost 0, and the limit value is equal to 0 is what we say. So that's the first one. For the others, I've given you the same polynomial so that we don't have a fuss calculating it. So what we see in the next one is the bottom one is x minus 2. So when I put x as 2, it's a 2 minus 2, that means it is tending to 0. So this becomes a problem of this kind, tending to 0 in the denominator as well as tending to 0 in the numerator, which we just calculated over here. Hence, what is making the numerator 0 and the denominator 0, those factors have to be cancelled. So what is making the denominator 0 is clearly x minus 2. No matter what, x minus 2 must be a factor of this polynomial, then only that polynomial is becoming 0. You have done in class 10 that if you have a polynomial x and when you put the value of x as alpha, or I'll not put a fancy letter, say you put a value of say a and pa becomes 0, it means that px must be having a factor of x minus a apart from some other polynomial left. So that is, in simple terms, when px is divided by x minus a, on doing the long division you get no remainder, the remainder is 0 and the quotient is qx. So what is over here? Let us just factorize this. I hope you can easily divide this with this or just split the middle term. I have given a very easy polynomial over here. So when you split the middle term, what you get is x minus 2 into x minus 1. I am not doing this step for you. I hope you can do it. Now mind you, x is not 2. Hence this thing is not 0 and hence I can cancel x minus 2 and x minus 2. A division by 0 is not allowed. But a division with a number which is very near to 0 is very much allowed, and these two numbers are same. So what we are left out with is x minus 1, and that limit thing is still there. I'm just not writing it. It is still there. Limit x tends to 2. Now it's a no problem one because at the bottom we have a 1. On the top we'll just plug in the value 2 minus 1. 2 minus 1. So I plugged in, instead of x, I plugged in 2, this value of limit 2 over here. So 2 minus 1 is 1, hence the answer is 1. So you can say the answer is tending to 1, the limit answer is 1. So I hope you have got this also right. So this one was of a problematic kind of 0 by 0, but we eliminated the 0. So while doing the limits chapter, you'll get very cool ones and you'll just enjoy figuring out how to eliminate the 0, and that I hope would be a fun chapter for you. So just to give you a glimpse, had this expression been at the bottom, I'll just multiply with something, x square plus 2x plus 3. Now they will not give you, now this expression is still tending to 0 at the bottom because this is tending to 0, 0 into something is 0 and the top one is also 0, so it's a 0 by 0 kind, and they are not going to give you all this in a boxed up way like this, the factorized way. They'll actually multiply and you'll have some x cube over here, some x squares, some x and some constants, and then that expression when you are going to plug into, it will be tending to 0 because it has got a factor of x minus 2. So you have to divide that expression with x minus 2, get that factor out, get that factor cancelled with the top one and get the answer. So it's just the same thing, but they'll try to increase the number of steps. So right now we are not going into limits kind of question. What we are trying to understand is what is limits, how to evaluate some simple limits. The in-depth difficult questions and all are going to come later. Right now we just want to know the how to evaluate some easy limits. So let us do the last one again. So what is the last one? The bottom one is tending to 0, we know, because we have just seen it's the same expression. The top is not tending to 0. So this is of a kind of something not equal to 0 and something tending to 0. So my answer would rush to infinity. Say 2 by almost 0 is a big number, infinity. And if the 0 is a negative 0, it is a minus infinity provided p is positive. So let me see what is the numerator tending to. Numerator is tending to 2 minus 1, which is 1. It is tending to 1. And the denominator is tending to 0. Now here, when we evaluate the limit, we have to see what happens when it is tending to 2, x is tending to 2 from the right hand side or the left hand side. Because this answer can be either plus infinity or minus infinity depending from which side it is tending to 0. So writing this expression as x minus 1 divided by x minus 1 into x minus 2. Okay, so this thing cancels, x minus 1 cancels, so we have 1 by x minus 2, limit x tends to 2. So we'll break this into two parts. One is limit x tending to 2 from the positive side, means x is just greater than 2, and the expression is x minus 2, and the other one is limit x tending to 2 from the left hand side, which means x is just less than 2, 1 by x minus 2. So what will this give you? What will this give you? This will give you 1 by almost 0, but since x is just greater than 2, this number will be just greater than 0. And what will this give you? 1 by a number which is just less than 0, denoted by 0 minus and 0 plus. So obviously the numerator is positive in both places, so this answer will tend to plus infinity, and this answer is going to tend to minus infinity. I hope this is in the screen, or I'll just write it over here: minus infinity plus infinity. So you see that the left hand limit is something else, the right hand limit is something else, and hence if you are going to graph it, this will be like way apart, and it would not be a continuous function over there. So that discussing continuity and differentiability and all is not the purpose of this class. So what we should right now know is this can yield two different answers, and that is enough for us.